Welcome to another brief overview of Agilent ESOF's Advanced Design System. This time we're looking at what's new in Release 2005A. In this release, we focused on making significant simulation technology improvements. I think you'll find that 5A is also easier to use, but you don't buy EDA software just because it's easy to use. You buy it because it has the simulation tools you need to get the job done. So let me show you how ADS 2005A can help turn your ideas into reality faster. Here we have two identical computers. On the left is ADS 2004A, the previous release. On the right is 5A. In both systems, we're going to perform a harmonic balance simulation of this receiver. I'll start the simulation on both computers at the same time. The 5A simulation finished in a little over 1 second. Our R&D simulation team really outdid themselves in adding a great deal of intelligence to how we even approach doing a simulation in this release of the Advanced Design System. 2004A completes in about 18 seconds, as you can see. That's a big difference, but it's not due to just a speed improvement. ADS 2005A now examines several things about a circuit before it gets started. It looks at the size of the circuit, how nonlinear it is, the interconnections, the topology of the circuit, and it checks the amount of memory available to avoid going into swap. 5A then approaches the simulation in a more intelligent manner. In this simulation, the 2005A release gathered enough information to know it could use the faster Krylov solver for this particular circuit. 2004A chose the direct solver based on the simple rules built into that release. The key thing is, we didn't have to figure out if the Krylov solver could be used with this circuit or not. The additional intelligence in 2005A did it for us. We have also improved the raw speed of the simulator. The total time it took to run our test suite of 381 circuits was over 5 times faster in 5A versus 4A. For larger, difficult circuits that took greater than 10 minutes in 4A, we've seen a cumulative speedup of 7 times faster. Of course, the speedup varies from circuit to circuit and is generally faster for larger circuits. But here's what's important. The total time it took to simulate all 381 test suite circuits in 5A with default settings was faster than in 4A with optimized settings. That means that your circuits will converge more often and solve faster without you having to adjust anything in the simulator parameters. We still allow you to get under the hood to change the simulator engine parameters and have even made this process more intuitive by adding settings such as robust or fast, and you can still set advanced parameter values directly. But the best practice now is to set everything to auto and let ADS 2005A do the work for you. Now that's easy to use. Since our harmonic balance simulator is the heart of many other simulation technologies, such as envelope simulations, oscillator, noise, optimization, and yield analysis, these improvements are seen there as well. Now I'd like to tell you about the 3 most significant improvements in the past 5 years to Momentum, our 3D planar electromagnetic simulator. Here you're looking at the layout of a silicon spiral inductor. Using the Momentum visualization feature to look at the 3D layout, you can see that the thickness of the conductors and their proximity to each other will have a significant effect on the inductor's characteristics. We performed a simulation of this inductor using this simple mesh. With just one cell across the conductors, the simulation took 17 seconds. You can see the results for the inductance compared to measurements are reasonable, but the results for Q are less accurate. Since most of the current is at the edges of the traces in this inductor, we used edge mesh in a second simulation. With edge mesh on, we get a mesh that will do a better job of capturing the current distribution in the conductor, but this more complex mesh causes the simulation to take 8 minutes and 15 seconds. However, you can see the results for Q are much more accurate. Well, I haven't shown you anything new yet. I've simply shown you that to get more accuracy, you need a more complex, longer simulation. No news there. However, Momentum 2005A now models horizontal current in the sidewalls of thick conductors. With edge mesh off and the new horizontal current feature turned on, the simulation is not only a quick 19 seconds, but it's also accurate. So horizontal currents in Momentum 2005A allow you to accurately model the 3D effects of thick metal conductors in a fraction of the time of previous releases. The second new feature in Momentum is a new type of solver. It's an iterative solver. It's analogous to the Krylov solver used in harmonic balance simulations. With the iterative solver, simulation times are a function of the square of the unknown currents in the structure. For Momentum's full-wave solver, simulation times are a function of the cube of the unknown currents. This means the iterative solver will solve large problems faster, as was the case with this filter, which took over 12 minutes to simulate with the full-wave solver, but only 2.5 minutes with the iterative solver. The good news is, Momentum examines the problem and chooses the best solver for you. If it has any problems converging with the iterative solver, it switches to the full-wave solver automatically. The third new feature of Momentum is an industry first. It's a 64-bit version of the Momentum engine, and there's no extra charge for it. It's included when you purchase Momentum. Running the 64-bit engine remotely on Linux or Unix machines makes it possible to simulate problems that were previously unsolvable. This 4x8 patch antenna array that generates over 14,000 unknowns is one example. You can see the realistic 3D far-field pattern that Momentum 64 now provides. There you have it. 3 very powerful new improvements to the Momentum 3D planar electromagnetic simulator. Let me show you one more very exciting new feature in ADS 2005A. It's a new tool in our data display called front panels. Right now, there's only one front panel available, an eye diagram, which is useful for signal integrity applications. It has the look and feel of Agilent's digital communication analyzer, as you can see, and the algorithms behind these buttons are based on the same algorithms in the Agilent DCA. It's an exciting new feature because we are working with several of our instrument divisions to bring Agilent's world-class measurement algorithms and expertise, as well as ease of use, to more front panels in the ADS data display. In closing, I know your boss isn't going to ask you if your job was easy. Your boss will ask you if you got the job done. Hopefully you've seen that ADS 2005A does both. It makes your job easier, but more importantly, it provides smarter, stronger, and faster simulation technologies that will help you get the job done. There's a long list of improvements in this release that I haven't covered, but if you're connected to the internet, you will now be taken to a website where you can learn more about the Advanced Design System Release 2005A. Thanks for your time.